Welcome back again. This is Wi-Fi Tech Lab channel. We are still on the same topic of dynamic routing protocol. Specifically for this lab, we will configure something called BGP or Border Gateway Protocol. Let's check out the definition of this BGP. So it's basically the routing protocol that enables different autonomous system numbers to exchange routing information. Okay, remember our internet backbone, it's all running by autonomous system numbers. So let's check our network lab that we'll be utilizing here to do the configuration of these internal BGP and external BGP. So before we come to the configuration, maybe let's just check what do we have on our lab. Let's simplify it. So we have some access layer down there. These are access devices that we have. We have layer 2 devices. We have switch 1, switch 2, switch 3, switch 4, switch 5, switch 6 up to 7. These are all layer 2 switches that are existing on an access layer. We have client computers that are directly connected via the access link to the layer 2 switches, and we have actually segregated, or we have VLAN, multiple VLAN on our network. We have VLAN 50, VLAN 60, VLAN 70 up to 100. Okay, and we also have that VLAN. This is a default VLAN on the other router or on the other switch. We have the specific different class C IP address. As you can see here, we have 172.16.6.0 as our network ID of /27, which means we only have 30 IP addresses that we can use on these networks. These are subnets. So let's go to the distribution layer. Also, we have only two switches. We call these switches multi-layer switches. They are layer 3 switches which are capable of doing IP routing as well, in which we're going to feature today something called BGP. We will be running these BGPs routing protocol on these multi-layer switches. Okay, on our distribution layer, if you pay attention, they all have trunk links directly connected to layer 2 switches. Right, so if you go up furthermore, we can see that there is a core layer here which runs our routers. All of these routers, they are directly connected using BGP, in which we're gonna be configuring today. So also, if you pay attention, we have these AS or autonomous system numbers: 65 100, 65 200, 65 300, 65 400, and 65 500, 65 600 over here, and we have 100s over there. If you pay attention, you will notice that each autonomous system number is actually different. Okay, so let's go back to the internal BGP and external BGP. What is the difference between the two? Well, let's start by internal BGP. Those BGPs, they actually exchange information between the routers of the same autonomous system number. So basically, if we can go to this route over here and say this is 65 100, the communication between the two, it actually will be existing between same autonomous system number. So which means these routers now, they're on the same autonomous system number. This is an internal BGP. However, because we have actually quite different autonomous system number over here, we have 200 and here we have 100, therefore we have external BGP. I hope that makes sense. Now, for the reason being that the version of our application that we're using to configure these BGPs, we are not gonna be configuring internal BGP because it's not supported. We're gonna see as we dive into configuration that it won't support it. However, it can support external BGP unless when we move to EVNG or PNet or GNS3. Therefore, we can be able to configure internal BGP to demonstrate how does it work. Okay, now let's go to what we're gonna do here. We have already assigned the IP addresses to all of these routers. As you can see, we have actually 10 to 10 to 10 to 10 between router 1 and router 2. This is the network ID. That's gonna allow only 2 usable IP addresses between these devices. Same thing applies over here. This is a different subnet. This is also a different subnet. Okay, So we're gonna check and verify if we have all of those IP address assigned on all of these interface in on each and every router on this network, okay, on the core layer. Now let's start and check what do we have. So let's start by router 1. On router 1, all we have to do, we have to navigate to the global config mode by typing the command config terminal. Okay, from the config terminal we can then run the command, do show IP interface brief. Okay, this is gonna show us the information about these interfaces as well as the IP address assigned to them. So as you can see, we have this fast Ethernet 0/0, which is this interface over here. We have assigned this IP address of 20.20.20.20.1. As you can see, this is the network ID that we'll be using between these multi-layer switch 1 and that specific router 1. So the first and the last usable IP address here is gonna be 20.1 and 20.2. And then let's go to this one over here, which is 6.0 gigabit 6/0. That one, it actually uses 10.10.10.1. okay, and if we go to this over here, it belongs to 10.10.10.4 network, which means the first usable IP address that we can use here is .5. okay, so same thing applies to router 2. If we go to router 2 global config mode, we will notice that when we run the command do show IP interface brief, we will see that there are two directly connected interfaces here on that router. We have gigabit 6/0, which is this one, which have the last usable IP address of this network ID, and we have also something called gigabit 4/0, which is the first usable IP address of the network range, which is 10.10.10.12. The first usable IP address will be .13 and the last usable IP address is going to be .14. Okay, in which we are expecting to see on that gigabit 5/0 on that router. Now let's move along to that other router, which is router 3, and see what configuration of the IP addressing is in there. Do show IP interface brief. Okay, as you can see, we have actually 4 directly connected interfaces. We can verify that by coming here. As you can see, we have 1, 2, 3, 4, but for now we're trying to check this one. Let's see on a gigabit 5/0. As we said, this is the last usable IP address of that network ID. Now what about 4/0? 4/0 is actually directly connected to this interface over here, which is located to router 4. So this interface will have .9 and that interface will have 20.20.5. so this fastnet 0/0 is actually have 20.20.20.5. okay, now what about that gigabit 6/0? It will have the first usable IP address on its network range, which is 30.30.30.1. alright, now we have verified on that router itself. Let's go to router 4 and see what we have. We already know that we have 2 directly connected interfaces. So if I come here and do show IP interface brief, I'll be able to see that there are 2 assigned IP addresses on that router interfaces. So we have that 10.10.10.10 on gigabit 4/0, and we have 10.10.10.6 as the last usable IP address on this range of 10.10.10.4. so this interface have that 10.10.10.6. okay, now what about this router over here? This router, it also have 2 assigned IP addresses on its interface. So let's type the command config terminal to show IP interface brief. As you can see, we have that 30.30.30.2 is the last usable IP address of its network ID, and also we have that 192.168.54.1 as the default gateway of that router. Alright, so now let's go check our multi-layer switches. These are the redundancy switch, just in case if one of them goes down, the other one will carry on forward the traffic. Now let's come in here and see what do we have. Enable config terminal, and then I'm just gonna configure the host name here and call it multi-layer switch 1. And then from here we can see which IP addresses are assigned here. Do show IP interface brief. Currently we didn't assign any IP address in here because the way that we assign the IP addresses on multi-layer switch is quite different. We need to enable something called no switch port on the interface that we're willing to assign the IP address. Let's just do it now while we're still in here. So we need to select the interface that we're trying to configure its IP address. So let's come in here and say interface gigabit. This is 1/0/7, and from here we're just gonna type the command no switch port. But I'm not gonna type it now. I want to make an example. What would happen if we were to try to assign an IP address without typing that command? 20.20.20.2, because we know this is the last usable IP address of that network range. 255.255.255.252. This is the subnet mask that falls under /30. So as you can see, it says invalid input detected. However, if we go back and type the command no switch port, therefore the interface is gonna go down and then it's gonna come up. As soon as it come up, we can then type the same command to assign the IP address. Therefore we have that IP address being assigned on that interface. Okay, by default all of those interfaces they are on a upstate, so we don't need to hook them up. Okay, so what we can do now, we can just verify if we can be able to ping the IP address of, let's say, do ping 20.20.20.1, the IP address of the interface on R1. So if we send those ICMP, we will see that we have dropped one packet. If we run it again, we can successfully get the reply 5 out of 5. Okay, now let's go to the second one and do the same configuration. I'm just gonna come in here, say enable config terminal, and then I will select the interface that I'm trying to assign the IP address to. In this case, I'll just select interface gigabit 1/0/7, and I'll type in no switch port, and then I can assign the IP address of 20.20.20.6 255.255.255.252. I don't need to type no shutdown, so I can ping now. Ping 20.20.20.5. Let's give it some time. As we can see, we can successfully ping 20.20.20.5. What if I were to try to ping 20.20.1? Let's see what's gonna happen. As you can see, all of the packets that we send are being dropped. Now we're gonna come back and run the same ping again after we have successfully configured the BGP. So let's just give it some time for now. Okay, so what we have to do now, we have to go back to our routers and start configuring something called external BGP. How do we do that? We need to go to that router over there. Let me try to move this aside. So we're trying to pair these two routers together, router 1 and router 2 at the moment. So how do we gonna do it? We're gonna first type the command route BGP, and then we need to specify the autonomous system number that our router belongs to. Our router belongs to the autonomous system number of 65.100. It belongs to 65.100, and then sorry, it's BGP, not BPG, so it's BGP. And we need to specify our neighbor's IP address that we're trying to pair with. In this case, our neighbor's IP address is actually 10.10.10.10.2. 10.10.10.2. As you can see, this is our interface that we're trying to configure its IP address in here. And also we need to specify the remote autonomous system number that we're trying to peer with. In this case, this is an external. Now, before we go to that different autonomous system number, let's see how we were to configure something called internal in this case. If I was to configure the same autonomous system number 65100, that was going to put us on the same internal BGP. So if I were to configure here, as you can see, it says this application that we're currently using is not supporting the internal. However, it can support external neighbors. All right, which is why we're going to demonstrate using these different autonomous system numbers to configure the external BGP. In this case, let's change it to 65200 and see what's going to happen. Exactly. So now we have initiated this session over here of configuring that neighbor's IP and the remote autonomous system number. What else we can configure here? We need to advertise some network. In this case, I'm just going to advertise that network of 10.10.10.0, and I need to specify the mask in here. The mask is actually 255.255.252 because of that /30 that we have, and then I'll just say do right. I'm saving my configuration now. Okay, now I can come here on router 2 and try to do the same thing in backwards. So which means now if I can try to peer R1, I will have to come here and type in the command router BGP, and then I will need to specify the remote autonomous system number, not the remote, actually the autonomous system number of router 2, in which it's going to be 65200, and then from here I can just specify the neighbor's IP address that we're trying to connect to or to peer to. It's 10.10.10.1 and the remote autonomous system number of 65100. Okay, as you can see now we have adjacency forming. Now these are actually neighbors now. Alright, these two routers, they are BGP neighbors, so we can actually advertise the network here of 10.10.10.0 with a mask of 255.255.255.252. Let's save our configuration, do right, exit. Okay, we have done configuring the BGP on that link between R1 and R2. Now let's focus on this connection between R2 and R3. How we're gonna do that? We need to do the same thing. We need to come here and type the command router BGP, and we need to specify 65200 is our autonomous system number, and we need to specify the neighbor's IP address that we're trying to connect to, the PA1. It's just gonna be 10.10.10.14. Remember the network ID that we're using here, and remember the last usable IP address of that network ID. So in this case, the remote autonomous system number is actually 65300, which is 65300. Okay, now we can start advertising those networks, which is 10.10.10.12, and we have to specify that mask 255.255.255.252. We can save this configuration, and let's go actually to this router over here. As soon as we do the configuration on this router, we're expecting to see the adjacency forming. Okay, now we need to type the command router BGP with the autonomous system number that our router sits on, which is 65300, and the neighbor's IP address, which is 10.10.10.13, and we need to specify the remote autonomous system number of 65200. Okay, now if I press enter, you will see that the neighbor is forming. Okay, now let's just put in that network 10.10.10.12 with a mask of 255.255.255.252. Do right. Okay, we have successfully configured the external BGP on router 3 towards router 2. Now what about router 4? On router 4, let's do the same thing. So we're just gonna start by router 3 and type the command router BGP. Our local autonomous system number is actually 65.300 and our neighbor's IP address is actually 10.10.10.10, because we know that the first usable IP address is in here on this interface, and then the last usable IP address is that interface on R4. So all we have to do now, we need to specify the remote autonomous system number of 65.400. Okay, 65.400, and then we need to specify the network ID of 10.10.10.8 with the mask of 255.255.255.252. Do right. Okay, now let's do the same thing on this router here, which is router 4. Enable config terminal. Let's say do show IP interface brief here. Exactly, we have that 10.10.10.10. Now let's configure BGP here. Router BGP. Our local autonomous system number is actually 65.400. As you can see, it's 65.400, and we're trying to pair with that router over there, which is having the IP address of 10.10.10.9, and we know that the remote autonomous system number that we're trying to pair to is actually 65.300. As you can see, we have adjacency forming now. Let's further advertise the network again of 10.10.10.8 with a mask of 255.255.255.252. Do right. While we're still on R4's global config mode, we can actually try to link or try to pair R4 to R1. How do we do that now? We need to actually type the same command router BGP, our local autonomous system number of 65.400, our neighbor's IP address, we all know that is 10.10.10.5. So let's type in 10.10.10.5, and we know the remote autonomous system number is actually 65.100. Network is actually 10.10.10.4. The mask is actually 255.255.255.252. Do right. All we need to do now is to go back to that R1 router BGP 65.100, neighbor's IP address of 10.10.10.6. Remote autonomous system number is 65.400. Okay, let's verify that. We know that the last usable IP address on that network is 10.10.10.6, which is assigned on this interface, and we also know the remote autonomous system number is 65.400. As you can see, the adjacency is forming now. These two routers, they appear together. They are actually neighbors. So let's advertise the network furthermore. 10.10.10.4, mask of 255.255.255.252. There are more configuration that we can actually do in here. However, we're not gonna do them because we are using Cisco Packet Tracer. Let's now go to this multi-layer switch. So on multi-layer switches, we can't just go and feature that BGP just like that. We need to actually type the command IP routing to enable routing on multi-layer switches 65 500 for instance. As you can see, IP routing is not enabled, so we need to type the command IP routing first, and then from here therefore we can configure any dynamic routing protocol. So route to BGP 65 500. We know our neighbor's IP address is actually 20.20.20.1, 20.20.20.1, and we know the remote system number of where we're trying to peer to is 65 100. We know the network that we're willing to advertise is 20.20.20.0, and the mask is actually 255.255.255.252. Okay, now that we are on a distribution layer, we would like to also advertise these subnets. Okay, for the purposes of, if these network IDs they're trying to break out to the internet, they will actually make use of this router or on this multi-layer switch to have some routing protocol running here, and they must be advertised in here, so we need to advertise them. So we know all of them, so we need to come here and say 172.16.6.0, and the mask is actually 255.255.255.224 because these are /27, and we need to do this in all of them. /64. Okay, let me just put on some charger here. Okay, now let's move on to the next one, which is 60. Okay, sorry about that, I went backwards. So which is 96. The other one is just gonna be 128, and the last one should be 160. Let's verify here. The last one is actually 160. We're not gonna include this one. Okay, now let's save our configuration. So let's go back to that multi-layer switch also and do the same configuration. Enable config. Now from here we need to enable IP routing again, router BGP, and we know our local autonomous system number is actually 65 600. Okay, let's go back. Okay, so basically because of the range that we have, it end up to 65534, we actually have to change this into lower number. Let's change it to 65. It's fine. Let's make it 6500. Now we know the neighbor's IP is actually 20.20.20.5. This is the neighbor, which is R3, 20.20.20.5, and then we know the remote autonomous system number is 65 300, and the network is actually 20.20.20.4, and the mask is actually 255.255.255.252. Let's include other subnets as well, which is 172.16.6.0, and we know the mask is 255.255.255.224, and let's include all of them. .128. Let's go to the last one, which is 160. Now let's save our configuration. There is no adjacency forming because we still need to go back to these routers, which is router 2 and router 3, and ensure that we have same configuration pointing towards the multi-layer switch. So we need to say router BGP 65300. The neighbor IP address we know is gonna be 20.20.20.6, and the remote IP autonomous system number is actually 6500. As you can see now, they have formed the adjacency. Now let's save this configuration and go to do the same thing on the router. Exit router BGP, and we need to specify that autonomous system number where our router is sitting. From here we need to specify the neighbor's IP, in which we know it's 20.20.20.2, and we know the remote autonomous system number is actually 65,500. As you can see now, there is adjacency forming. Now what does that symbol mean? It means we can be able to ping any IP address of any router on this BGP domain. So which means we can actually ping from here towards that router, towards that router, towards this router. But let's wait until we do the configuration of on this router, and then we're gonna run some final test over there. Config terminal, router BGP 100, neighbor's IP is actually 30.30.30.1, and the remote is actually 65,300. Let's see, is 65,300, and the network that we're willing to advertise is actually 30.30.30.0, and the mask is actually 255.255.255.252, and we're also gonna include this 192.168 dot 54.0, and the mask is gonna be 255.255.255.255.0. do right. Okay, we have included this network ID of 192.168.54.0 on that router's information. Now let's go to this router and try to peer to that router over there. Router BGP 65,300. Okay, let's go back and change this BGP. The neighbor's IP address we know it's gonna be 30.30.30.2, and the remote is actually 100. As you can see now, they have form adjacency. And let's further advertise this network of 30.30.30.0 with a mask of 255.255.255.252. do right. So we have actually successfully configured something called BGP, specifically external BGP. Now it's time for us to do our testing, even though we're still gonna configure the DHCP server and the DNS, and then we can go and configure all of those VLANs and ensure that we can ping from any device in here towards any IP address of all of these routers in the network. Okay, now what we're gonna do is we're gonna run a test from these multi-layer switches. Exit. We want to ping 30.30 remember 30 is sitting on that interface. We want to ping 30.30.30.2 from where we are. Okay, it says that this is forbidden. Okay, it's fine. We're trying to ping, actually we're not trying to connect to it, so we're trying to ping. As you can see, we have successfully pinged that 30.30.30 over there, so which means we can also try. You remember last time we couldn't ping from this device, we couldn't be able to ping that interface to ping 20.20.20.1. we couldn't be able to ping, but now we can be able to ping utilizing something called BGP. Do show IP BGP. As you can see, we have now routes, BGP routes on our routing table, and let's go and do something called do show BGP summary. Do show IP BGP summary. As you can see, we have some neighbors in here that we have 20.20.20.5 for that multi-layer switch. Okay, so if I can run the same command on all of these devices, we can be able to see all of these informations. Okay,